All right, welcome back, everybody. Mr. Anderson here again for a update or I don't know. I guess we're going to restart Algebra 2 here again. So, hope you had a great Christmas and a great J term. And what we're going to do is we're going to get back into a little Algebra 2. We're in Chapter 5, Section 1. We're going to talk about operations with polynomials. The good news here is that most of this I think you've probably done in one form or another before, so at least it won't be too difficult to get started. So that's something to look forward to. All right, well, let's go ahead and just get going here and see what we can do. Our objective for today, first of all, is to multiply, divide, and simplify monomials and expressions involving powers. Again, we've done some of this stuff before. And add or subtract and multiply polynomials. We should have done that before too. So hopefully nothing totally new here. All right, first of all, simplifying monomials. All right. First of all, a monomial is simplified when there are no powers of powers. Okay, so we've got to take care of that. Anything a power raised to a power, we have to work that out. Each base appears only one time. So if you have like x squared on the top of a fraction and x to the fifth on the bottom, we have to combine those, get those combined. Or if you have like a y to the fifth times a y to the seventh, we have to get those combined as well. So we can't have more than one base in there. We combine those. Any fractions that you have need to be simplified. And we don't want any negative exponents, okay, because that's something I don't know if we talked about that this year, but in Algebra 1 we've talked about that, where negative exponents are kind of a little hard to wrap your head around. So anyway, we want to get rid of that to make it as simple as possible. So here's some of the things that we're looking for, okay? So let's take a look at a few more specific things. Just kind of we'll go over a few of these things here, and then I'll work out a few examples with some of these things in them. Just to kind of refresh your memory, the product of powers, that means if we're multiplying two things, they have to have the same base, x and x, here. And the exponents then will add. So if you have, here's a better example. Let's look over here where we have some numbers. P squared times p to the 9th, that means we're going to add 2 plus 9. So p to the 11th will be your answer there. So remember, exponents always do something a little differently than the main thing. So like here, we're multiplying, but what did we do with the exponents? Added. Okay, so remember, we're always doing a little something different with the exponents. Quotient of powers means when we're dividing, then we subtract the exponents. So here, if you have b to the 6th over b to the 4th, we do 6 minus 4, b squared. Now they don't have an example here, but let me do something over here to the side. If you had, instead of b to the 6th over b to the 4th, let's say you had b to the 4th over b to the 6th. If you had that, then this would be 1 over b squared. So you'll still subtract them, but where the exponent will be positive, how you want to have it, because no negative exponents, remember, is, in this case, the b squared will be on the bottom. If you did 4 minus 6 is negative 2, that would be on the top. Then you'd have to flip it to the bottom to get this 1 over b squared. Which then leads us right into this negative exponent here. If you have, say, 3 to the negative 5th power, to get rid of that negative exponent, remember we flip it to the bottom, so it's 1 over 3 to the 5th. Or if it's on the bottom already, 1 over b to the negative 7th, flip it to the top to make it positive b to the 7th, really over 1. We just don't have to write the over 1 part. Power raised to a power. If you have a power raised to a power, you multiply. So if you have d squared to the 4th power, 2 times 4 is 8. Okay, so you can see the 8 here. If you have something in parentheses, the whole thing is raised to that power, you can take each thing that's being multiplied together in there and raise it to that power. So, for example here, AB all raised to the third power. You can do a to the third power and b to the third power. A to the third, b to the third. Same thing applies with the quotient, with division. If you have x divided by y, all raised to the a power, x can be raised to the a power and y. So for example, like over here, x over y squared, you've got x squared over y squared. With the negative exponent here, you could do this one of two ways. Either, well, the way that they've done it here is if you have a negative exponent out here and you have a fraction, you can make this negative power out here positive by just flipping the whole entire fraction. So instead of x over y, you've got y over x to the positive a power, then do y to the a power and x to the a power. So like for example here, you've got a over b to the fifth power, flip the a and the b, top and bottom, then you do b to the fifth and a to the fifth. The other way you could have done that is to gone a to the negative fifth and b to the negative fifth over b to the negative fifth, and then switched each one of those separately, and you'll still end up with this b to the fifth, a to the fifth down here. And the last power here is the 0 power. Just remember, anything to the 0 power always equals 1. Always equals 1. Doesn't matter what it is, anything to the 0 power is always 1. Okay? So a quick little review of some of the properties. Let's work out a few examples here. Here's an expression. A to the negative third, and then times a squared b to the fourth, and times c to the negative first. Well, first of all, you notice we've got negative exponents. So let's take care of those first. So what I'm going to do is, you know, in this case, think about all of these as like being over 1. And then what we're going to do is we're going to take the a to the third, negative third, and move it down, and the c to the first and move it down. So here's what we've got now. I've got a squared b to the fourth over a to the third c, or c to the first. Okay, so first of all, we got rid of the negative exponents. Good. But now the other thing is we've got two a's here. We've got to combine those. And so remember, we're dividing, so we're going to subtract. But we're going to subtract in a way, because there are 3 a's on the bottom and 2 a's on the top. My final answer, where it's going to have a positive exponent, will be on the bottom. So I'm going to do 3 minus 2 is 1, but that a to the first is going to be on the bottom. And then of course c, there's no other c's, so that just stays there. And then we've got b to the fourth up there. So b to the fourth over ac. Okay? Hopefully this is coming back to you. Here's another one that's already in fraction form. We've got some numbers in here. And so remember, we talked about simplifying the fractions. All right? Well, this 6 and 9, we have to simplify that fraction. So if you look at that, you go, well, 6 can be divided by 3 and 9 can be divided by 3. So what we're left with here is 2 over 3. It's usually best to keep these just as a reduced fraction, not to make it a decimal, especially if there's other stuff, or yeah, not to make it a decimal, especially if there's other stuff in here. So just leave this as a reduced fraction. And then I've got the x's need to be combined, so what can I do? 9 minus 2 is 7. Where's it going to go? On the top, because the bigger one was on the top. So we got x to the 7th on the top. And then with the y's, I can subtract, and I can do 7 minus 3 is 4. But where's that going to go? That's going to go on the bottom, because the bigger exponent was on the bottom. So since you did 7 minus 3 is 4, that's going to be on the bottom. And so in this case, that's your simplified version. All right. I think I got one more of this kind. Here, notice we've got this whole parentheses raised to a power. You can do one of two things here. You can, if you want to, you could take 6 squared and then r squared squared, 3 squared, and s to the third squared. You could square everything in there and then simplify it from there. But you also could simplify what's inside first and then take whatever's left squared. That might be a little bit easier because if you notice here, if you do 6 squared, it's going to be 36, and 3 squared is going to be 9, and then you have to do 36 divided by 9. Not the worst thing in the world, but 4, right? Well, what if we just first did 6 divided by 3 is 2, and then we did 2 squared, 4. We get the same exact answer, but that was probably a little easier. So in this case, let's do that first. I'm going to do 6 divided by 3 is 2, and that's 2 on the top. So it's really like 2r squared over s to the third. Once I simplify this, the 6 and the 3 squared. Now I can take each part on top. I can do 2 squared, which is 4. R squared squared, which is r to the fourth. And then down here, s to the third squared is s to the sixth. Okay? So 4r to the fourth and s to the sixth. We've gotten rid of the power raised to a power. We've simplified the fraction. And there's no bases that are the same. R and S are different. All right. Next thing is talking about the degree of a polynomial. I think we've talked about this before, but in order to find the degree of a polynomial, first of all, it's got to be a polynomial, which means each term has to be a monomial. So first of all, if you have a variable in one of your terms that has a square root in it, it is not going to be a monomial, so therefore the whole thing is not a polynomial. So for example here, like if you had 3 plus the square root of r, plus 16r squared, that is not a polynomial because the square root of r is not a monomial. No variables in the denominator. So if you remember before, like if we would have had like 3 over x plus 4 over y equals 16. That is not a, well actually I shouldn't say equals, let's call that plus there as well. That is not a polynomial because neither of these are monomials. And the other thing, no negative exponents, and based on what we were just talking about with negative exponents, why negative exponents wouldn't be good is because, if you say you had x to the negative 1, plus x to the negative, call that y, let's call it y to the negative 2 minus 5. Well, what is that really? This is really 1 over x plus 1 over y squared. And so just like the problem here is we've got what? Variables on the bottom. That's why we can't have negative exponents. Well, I kind of wrote over it a little bit here. But so to find the degree, first of all, it has to be a polynomial. And then the degree is going to be whatever the monomial is that has the greatest degree. So let's look at an example. That'll make more sense in a second. All right, here's a few things. You have to determine, is it a polynomial, and if so, what is the degree? First one, is that a polynomial? No, because of the square root of c there. Number 2, is that a polynomial? Yep, because you got negative 16 times p to the 5th, and then plus 5 times p squared times t to the 7th. That looks good. Everything in the term is being multiplied together. And then what we have to do is figure out what's the degree. Well, remember how we did this is you look at each one separately. So you look at that part. What's the degree just of that part? It's 5. You look at the exponent. Then you look at the degree of this part, and you've got p squared and t to the 7th. So within that part, you add the 7 plus 2 is 9. So that part is 9. Then between the 5 and the 9, you do not add them. You just take the biggest one, 9. So the degree for this one would be 9. And then last one here, is that a polynomial? Doot, doot, doot. Look at that, negative 1 exponent. So that is not a polynomial. Okay? So there's a few there with the polynomial. All right, last stuff here is we're going to do a little something with adding, subtracting, and multiplying with polynomials. Again, this should be pretty simple here. We are adding two polynomials. Well, when we are adding two polynomials, it tells us that because there's a plus sign in between them. And all we do are combine like terms. So I've got 4x squared minus 2x squared, which is 2x squared. Then I combine the negative 9x and the negative 5x, which is negative 14x. So we combine those. And then lastly, the 3 minus 6, which is negative 3. So just combine the like terms when it's addition. When it's subtraction, there's something we do before we combine the like terms, and it has something to do with this negative sign right here. That's correct. Distribute the negative. Very good. And so I just like to rewrite it first. So this 2a to the third plus 5a minus 7. Then it's going to be minus a to the third minus a negative, so plus 3a minus 2. I just like to rewrite that where I distribute the negative, and then that way I'm less likely to get confused later on. Okay, now that I've done that, combine the like terms. I've got 2a to the third minus a to the third is 1a to the third. I have 5a and 3a is 8a. And last but not least, I have negative 7 and a negative 2, which is negative 9. Okay, so when it's subtraction, distribute the negative and then combine like terms. All right, multiplying. First of all, if you are multiplying a monomial by a polynomial, well, you take a look at that and you go, well, that's basically, we're just doing the distributive property, right? So all we do is just distribute that 3x. Again, this should not be too terribly bad. So I've got 3 times 2 is 6x to the third. Remember, when we're multiplying, we add 2 plus 1. 3 times the negative 4 is negative 12. X times x is x squared. 3 times 6 is 18. And you also have the x there. Notice in this case, you have x to the third, x squared, x. None of them are like terms, so we do not have to combine any further than that. That's our answer. Just distributive property. But pay attention when you're distributing what you do with the exponents. Okay? And then the last one, we are multiplying a polynomial by a polynomial, in this case a binomial by a trinomial. And so all this means is I just have to make sure I take this a and multiply it times all 3 of those, and I have to take this 2 and multiply it times all of those. All right, so let's start with the a here. A times a squared, a to the third. A times 3a is 3a squared, and a times negative 4 minus 4a. All right, I just distributed the a. Now let's distribute the 2. 2 times a, or 2 times a squared, 2a squared. 2 times 3a is 6a, and 2 times the negative 4 is minus 8. So I just distributed the a and I distributed the 2. Now all I have to do is combine like terms. Remember what we did on the last screen there? So I'm going to do it in descending order. Biggest power of a first, so I've got a to the third. And then I've got 3a squared and 2a squared, so that's 5a squared. Notice when I'm adding, the exponent stays the same. It doesn't change. That's when it's multiplying, it changes. Negative 4a and 6a is 2a. And negative 8, there's nothing to combine that with, so it stays like it is. A to the third plus 5a squared plus 2a minus 8. is our answer. And again, we've done that before, so this shouldn't be anything totally new to you. One thing I will mention, though, what I would suggest, I'll do a little squiggly line here. If you had, you know, say 3, if you had 3, say, binomials, I mean, even if one of them is a trinomial or something, don't get freaked out. Just take, like in this case, the 3 that I've given you here. Got to find out where I am. Take these 2 and FOIL them first. So multiply these 2 together. So you're going to have x times x is x squared. And you're going to have minus 5x plus 2x minus 10. Combine the like terms, so you've got x squared minus 3x minus 10. So just pick 2 of them, multiply them together, and then take this trinomial times that binomial, which is what we kind of did over here, which we did over here anyway. So I'm not going to work all that out there, but you know what to do from there. Then you can just multiply, just like we did over here. So if that comes up and you have 3 of them, just pick 2 of them to multiply together first, and then take the resulting answer from that and multiply it times that third parentheses. Okay? So that's it. That's section 5.1, kind of a little review on what you do with all the exponents when you multiply, divide, add, subtract, and so forth. So that's it. We'll see you again soon in section 5.2. That's all for now. Bye.